Dear all, this week topic is different type of operation modes of op-amp, and this one is part 1. We'll have another part in next week. First, look at the content. We'll start with the op-amp comparator, then the zero crossing detector, positive level detectors, and finally the negative level detectors. So at first we want to start with the input terminals of an op-amp. In the figure there is an example of op-amp with the connection diagrams. The input terminals is negative and positive. That's when two input terminals, and it has the supply voltage of positive and negative supply voltage, and finally the output RL. That's when with the load connections, and there will be output voltage V0. So this V0 output, V0 voltage is dependent on the input terminals. And how this input differentiate input terminal. That's when the difference between negative and positive terminal will determine the output voltage of V0. So the difference between negative and positive is called the differential input terminals, ED. ED. So this one the ED, and that is the differential input terminals. And the gain of this amplifier is AOL. OL means open loop, because there is no feedback connections. That's why it is an open loop connection. So the gain will say AOL, A subscript OL. Here we can see that the output V0 is equals to AOL into ED. That's when the gain multiplication the differential input terminal voltage ED equals to plus V saturation, SAT saturation. So this is plus. Why plus? The output terminal is positive with respect to ground when the positive input is positive with respect to or above the negative input. So when the positive input is more positive, dependent on the negative input with respect to negative input, then the total output will be plus something. That's when plus V saturation. Why it is saturation? Because there will be a saturated voltage fixed. Suppose for this op-amp it will be 13 voltage. It is because of the construction of this type of op-amp. Now another example is given with the op-amp. This one the output voltage is minus V saturation, minus V. That's when it is a negative output. Why? Because the input terminal minus negative input terminal is more positive. That's why the output final output is minus. So for that reason ED is reversed here to make the positive input negative with respect to or below the negative input. That's when V outcome becomes negative with respect to ground. So VO goes negative only when the positive input is less positive than the negative input. Open loop voltage gain. So I mentioned earlier what is open loop voltage gain. So again the definition is given here. Output voltage V0 actually it is determined by the differential voltage ED and with the open loop voltage AOL. So this AOL cause called the open loop voltage gain, and the reason is why it is open, because the feedback connection is open from between output terminal to input terminals. So VO is expressed by the relationship. So VO equals to ED into AOL. That's when output voltage is equal to differential input voltage multiplication open loop gain. Differential input voltage. So we previously discussed the ED, differential voltage, and the value of AOL is extremely large for these types of op-amp, and that is approximately 2 lakhs or more. So VO, but VO, that's mean output voltage can never exceed the positive or negative saturation voltage. That's mean it cannot be more than V saturation, positive V saturation or negative V saturation. And what will be the V saturation voltage? I mentioned earlier, that is 13 voltage. That's mean positive 13 and negative 13. So whatever the input, whatever the um, gain value, the output voltage will be in between positive 13 and negative 13. So for a plus minus 15 volt supply, this saturation is normally will gate. Thus for the op-amp to act as an amplifier, ED must be limited to a maximum voltage of plus minus 65 microvolt. You can calculate this one. So this is the formula: ED max equals to plus Vsat divided by AOL. So if we put the values 13 volt divided by 2 lakhs, it will be 65 microvolt, and that is positive. And when we will calculate the minus ED max, so it will be minus V saturation divided by AOL equals to minus 13 volt divided by 2 lakhs. So it will be minus 65 microvolt. So please keep it mind that the output voltage will be plus minus 13 voltage. That's mean the V saturation, and minus V saturation whatever the input voltage we give. And that is this is because of the construction of the op-amp. So the data sheet will say that the saturation voltage is limited to this voltage. Comparator. So a comparator is a subsystem that compares two voltage. So this op-amp can actually act as an comparator. Act as a comparator. It will compare two types of voltage that will be given in their inputs. So it outputs indicate to which one is the larger and which one is less amount of voltage. So one use of this is to turn an analog signal from a sensing subsystem into a digital signal. So suppose there is a limit of voltage or level of voltage, it will say if the level of voltage is below that level, so it will show the output as 0, or if the voltage is upper than the level, then it will show the logic 1. So it will act as a digital logic output, and definitely it will, after comparing that voltage, it will show the logic between 0 to 1. So there are several types of comparator. We'll discuss one by one. Op-amp as comparator. First one we'll discuss about the single input. So the figure you can see, the output is connected with a resistor, 10 kilo ohm resistor, load resistance, and the output voltage will come from that resistance. There is a supply voltage positive 15 volt and negative 15 volt, and the input, it has positive input terminal and negative input terminal, both is connected. But you see the positive voltage source, that is zero point 0.1 voltage source, is connected in its positive terminal. That's why it is single input op-amp. In negative terminal, it is all directly connected with the ground. That's means there is no voltage source is connected. So only one terminal is connected with voltage source. That's why we are saying it is single input op-amp. Now the output resistance is 10 kilo ohm. The supply voltage is plus minus 15 volt. So input voltage, we know one is positive input voltage is 0.1 volt and negative input voltage is 0 voltage. And if the uh, open loop gain A is 2 lakhs, then what will be the output voltage? If we calculate with these equations, you can see here V output will be 20,000 volt. But will it show it 20,000 volt? No. I said previously that we have the saturation voltage, saturated voltage, positive or negative saturation. So it will cut the voltage on that saturation level. So whatever the saturation voltage is 12, 13 or whatever, it will cut that voltage or clip that voltage on that part. So the output definitely 20,000 voltage is not, but it will be positive saturation, V saturation voltage. Now the op-amp comparator for dual input. So what is the difference? You see here that with the op-amp we have two inputs, both are connected with the voltage source. One is 0.5 voltage source with the positive terminal, and another one is zero point 0.3 voltage source with a negative terminal. Supply voltage is same, 15 volt positive, negative 15 volt, and output is with a resistance of 10 kilo ohm resistance. So if we want to calculate these things, so the same gain, that's been 2 lakhs, and so V out is equals to gain A into ED, that's been differential input voltage, V input plus minus V input minus, so 0.5 volt minus 0.3 volt, and finally the result is 40,000 volt, but actually it will not show that. It will show what? It is 13.5 volt, because it has the saturated voltage of 13.5 volt due to clipping. So the final output will be actually 13.5 volt. That will be written in the data sheet that the saturation voltage is fixed on it 13.5. Non-inverting zero crossing detector. Now I want to discuss this type of detector. So zero crossing means whenever the zero level will cross, it will show the saturated voltage in its output of the op-amp. And what is non-inverting? The input voltage is connected in non-inverting side. That's why it is calling non-inverting. So non-inverting terminal is positive one. So and we know that the inverting terminal is negative one. So in this case, the input voltage is connected with non-inverting point, that is positive terminal in pin number 3. So you see that in the diagram EI, so input EI, that is a AC voltage source that is connected with the non-inverting terminal, and this input voltage, this AC actually a triangular shape. It is not a sinusoidal wave, it is triangular wave. In the right portion, the output and input curve is drawn here. So EI, triangular wave, it is drawn first, and depending on this EI, we will draw the output wave diagram. That's when V0, we'll draw the V0. So the diagram is V0 versus T diagram. That's been time dependent diagram. So whenever EI is above V reference is 0 voltage. That's mean in inverting terminal, input is connected the directly ground, so there is no voltage, so V reference is equals to 0. So whenever EI, that's mean input voltage EI is above V reference, then V0 will equal V saturation. Whatever the V saturation, it is 13 volt or 13.5, so output will show it V saturation. So in first part we see, because it is triangular wave, so first part is positive triangular and second part is negative. Again it is positive, it will be again in negative. In this way it will continuously show the input voltage. So again I am saying when EI, input volt source, is above V reference, that's been above the zero level, then output will go to the positive V saturation. And when this is because the voltage at the positive input is more positive than the voltage at the negative input. That's why the sign of it is positive. Consequently, V is positive. And you see when the EI is less than the V reference, that's mean in negative portion, then the V saturation voltage is also minus V saturation. That's mean second cycle, this one. And you see the input voltage when in positive cycle, then output is also positive. When the input is in negative cycle, the output is also negative. That's mean the output is not inverting. That's why it is called non-inverting. So whatever the input, whichever the sides, output is also in same side. That's why it is not inverting. That's mean it is in same directions. That's why it is calling non-inverting. So that is the basic difference between a non-inverting terminal and another one is inverting terminal. So it is non-inverting, so inputs and output is in same side. So we'll discuss the second part, that's been inverting terminal. We'll see that it will convert it to another part. So here the inverting zero crossing detector, and we can see the difference. The input voltage source is connected with inverting terminal, that's been in negative terminal, and rest of them are same. We have a supply voltage plus minus and the load resistance RL in output diagram, and the voltage V0 versus timing diagram is given in the right portion. So input voltage is drawn with a triangular wave. So when the triangular wave is in positive cycle, the output is in negative minus V saturation. So its input compares voltage EI with the reference voltage of V reference. So when E is more positive than V reference, VO equals negative. That's mean EI crosses the reference going positive, VO makes a negative going transition from V saturation to minus V saturation. Second cycle, EI is negative and output is positive. And next third cycle is EI is positive and then output is negative. So that's when a reverse direction. That's why it is calling inverting zero crossing detector. So whenever the zero is crossing, the output is changing and changing in inverting direction. Sine to square wave converter. We saw in zero crossing detector that it converts the output of a sine wave or triangular wave from a function generator into a variable frequency square wave. That's when whatever the input EI is, a sine wave or a triangular wave or a wave of any other shape that is symmetrical around zero, the zero crossing detector's output will convert it into a square wave. That's why we are saying sine to square wave converter. Positive level detectors, it is in non-inverting. So this type of op-amp detect the positive level of its input. You can see from the figure in the op-amp, the connections positive level voltage is connected as V reference in non-inverting terminal in negative terminal, point 2, pin point 2, and the normal input voltage EI is connected in inverting terminal. So actually this EI and V reference will compare in its input and then the output will show in VO. So whenever the V reference voltage will be whenever it will compare with the V reference, when EI will be more than V reference, then the output will be V saturation, positive V saturation. We can see in the output diagram in the right side, VO versus T diagram, input is drawn EI, that's been triangular wave shape, and output where you can see from 0 to V reference has some positive voltage values. It may be 1 voltage, maybe 2 voltage, or maybe 5 voltage. So whenever this EI is greater than V reference, then output will be plus V saturation, and whenever this EI is less than the V reference voltage, then the output voltage is minus V saturation. That's when it can detect the positive level by showing the output in V saturation, positive V saturated. Positive level detectors inverting now. So same thing like the previous positive level detectors, but it is inverting. That means the output will invert. The previous one was not inverted, that was non-inverting, but here the output will invert. You can see the EI is connected in inverting terminal, that's the input voltage, but the reference voltage, positive voltage source, is connected in positive side, positive terminal, non-inverting terminal. So when EI input voltage is above V reference, V output equals minus V saturation. That's mean it will invert in the opposite level. So we can see from the timing diagram also, output versus time diagram. Whenever the here you can see that EI is greater than the V reference here, positive side, then output is negative. That's mean minus V saturation. And when the EI is less than the V reference, then output is positive. So that's why it is inverting. So we are calling it positive level detectors inverting. Negative level detectors non-inverting. Now the op-amp will detect the negative voltage. That's mean in the reference there will be negative voltage is given. It is connected in point 2, pin 2. So that is minus V reference. That's why it is a negative voltage. And EI is connected in positive terminal number 3. So when EI is above minus V reference, then output equals to positive V saturation. We also can see it from the diagram. And when EI is below minus V reference, then output is minus V saturation. And the output is not opposite directions, it is in same directions of the input. That's why it is non-inverting. Negative level detectors, and that is inverting. The circuit is given here. We can see the negative voltage is connected in pin 3, that's mean in positive terminal, and the input voltage is connected in minus terminal. So when the conditions is when EI, the input voltage is above minus V reference, we can see from the diagram. When this EI is above V reference, then output is minus V saturation. That's mean in opposite direction, not in the direction of input EI. And when EI is below minus V reference, then the VO, that's mean the output equals plus V saturation. That's mean opposite direction. That's why the output is in opposite reverse direction. That is why it is calling inverting, because it is connected in input is connected in inverting terminal, and negative voltage is connected with the input. That is why it is called negative level detectors. Some applications of voltage level detector is adjustable reference voltage, sound activated switch, a light column voltmeter, and a smoke detector. Self-directed learning. So this week's question is a compare between zero crossing and voltage level detector. So please post these questions answer into our forum in due time. That's all for this week. Please follow the forum, and we have quiz also in this week. So please participate in due time.